my talk, Vibe Computing, AI-powered multi-cloud orchestration with Cloud-Barista. So first of all, 안녕하세요. Hello everyone. I'm Seokho. Welcome to Korea and for this nice event and the final session of this cloud and container track. So you know how to write 안녕하세요? So this how to write 안녕하세요 in Korean. Okay, so who am I? I'm Seokho Son. I'm from South Korea Electronics Telecommunications Research Institute, in short, ETRI, which is government-funded national research organization in South Korea. And in there, I'm a senior researcher and open source special fellow. And also, I like open source very much, and I do some activities and I do contribute to open source community, especially for cloud native community. And in there, I'm CNCF Cloud Native Computing Foundation ambassador, and I'm gathering several texts. And I think folks who are living in cloud native community, then you might see me, and I'm contributing to some repository, especially for the Kubernetes SIGDocs and cloud native glossary in CNCF. But for this talk, in this talk, I'm here as a maintainer of Cloud-Barista open source project. So let's record the title, quite complex, right? So Vibe Computing, AI-powered multi-cloud orchestration with Cloud-Barista. I think you never heard of Vibe Computing and Cloud-Barista. So I'm just curious. I think everyone knows what is Vibe coding, right? How about Vibe Computing? Have you heard? Anyone? Yeah, you shouldn't know actually, because I invented that word and I posted it in my tiny little repository, personal repository, and I actually thought this kind of term, Vibe computing, can be a new paradigm for after cloud computing, cloud native computing. The reason why I think like that is, AI gain power more and more and have lots of features. And now AI can create a program, software, and maybe it can deploy the service based on AI-generated software. In that case, I think AI will need computing resource as well. So I think we need to prepare a computing paradigm that can be fed to AI, agentic AI, and generative AI. So I invented this term, Vibe computing, abstracting the entire stack for computing as well as application and service deployment, and users no longer manage it, and they just simply intend with their Vibe. So if you see 1 year or 10 years later people use Vibe computing, then remember me, I wrote this first time. So impact, I'm going to talk about today. I'm going to introduce what is Cloud-Barista with multi-cloud capabilities, and we'll show additional feature based on the MCP, Model Context Protocol, and generative AI. And I think these two combinations might be foundation of the vibe computing, foundation of vibe computing, or just proof of concept. So I'm going to introduce, first I'm going to introduce Cloud-Barista with multi-cloud, and then the MCP for Cloud-Barista that I developed. So Cloud-Barista, yeah, also I have to ask, have you heard of Cloud-Barista? Yeah, very few. Yeah, I'm sorry. I should announce more, but I think Cloud-Barista is known for Korean little bit, but maybe internationally, globally, maybe few people know about Cloud-Barista because it was invented based on South Korea government R&D project, and we gained some awareness from South Korea, but we didn't spread it to globally yet. So maybe it is kind of first session talking about Cloud-Barista in this international conference to the audience from global regions. So I think most of you now know what is multi-cloud and why we need to use multi-cloud. If we use just a single cloud, we may face cloud outage. Recently, there's outage from AWS, right? Every service will go down. So we are very worried about using one cloud and one region. And we actually need to care of HA, high availability, but it requires money, right? So people only talk about multi-cloud when only some critical event issues arise. But you should also think of the cloud logging. If you are using just one cloud and you are keep using and you are too familiar with one cloud, in the case, maybe the cloud provider increase their price, then what are you going to do? You need to change cloud service provider, I guess. But yeah, one day, if you have to try using multiple cloud altogether, it's not easy. Maybe the reality is worse than you imagine. It is because cloud providers use different terms, APIs, methodologies, and different prices. For instance, there are four cloud service providers, CSPs, AWS, Azure, GCP, Alibaba, and it shows lifecycle status for virtual machine. So virtual machine can be created and postponed, resumed, restarted, and terminated, and deleted. And they are using different status and different terms. So if you are using one CSP and wanna use another one, then you need to understand the different concepts and terminologies, APIs. And if you use many cloud service providers and lots of resources distributed to multiple cloud, then yeah, management complex also increase. Also, second issue is cloud performance varies more than you think. For instance, if you compare AWS and GCP virtual machines performance, they are actually different. Even though the spec says the same, 4 vCPU and 16 gigabyte memory, if you actually deploy those virtual machines from AWS and GCP and compare, benchmark those performances, they actually shows different performance. And the price itself also different. So we don't know. Also in GPU domain, GPU infra, the price is more expensive than general CPU-based specification, VM specification. Then we always need low cost and high performance and high security. But if you think about if you are using 10 CSPs, how do you know which one is the best one? And these days we are lack of GPU area. And do you know where is HVAC GPU in cloud? Maybe you can find it from one CSP, there's information. But if you want to find it from different CSPs or very limited zones, then you are harder to find. Also, if you actually deploy the virtual machines and node, computing node in cloud area, if you compare the latency, then they are all different because they use different network architecture and connectivities, even in one CSP. So that's the reason why we started this Cloud-Barista project. We actually, nobody knows Cloud-Barista yet in this session, but we actually started it from 2019. Yeah, Cloud-Barista is an open source project and community to provide essential capabilities and functionalities for building multi-cloud solutions. So we spent almost 7 years to provide this kind of capability to world actually, to South Korea first and then to world. No. So as you noticed, this one, Go4, yeah, Cloud-Barista is based on Go language. We wrote from the scratch by the Go language. So what actually the Cloud-Barista can help? So in this world, there are many cloud service providers, CSPs, and they keep expanding their service area. That means they are deploying data centers worldwide. They say it is a region or availability zone that they are distributing covers all the world. So as I know, for 9 CSP, some known CSP, if we calculate all the regions, it is around more than 180 regions. But we cannot fully use those regions and CSPs yet. But with Cloud-Barista, you can use a little bit more. So we gather all the information from all CSPs, and those CSPs usually provide open API and SDKs that can support programmatically use their cloud service. But as I mentioned before, their terminologies and the way to use those APIs are different. So we first provide abstraction of those APIs. So we provide heterogeneous cloud abstraction first. Then we can easily create cloud resources based on this unified abstractized API. And then we provide some kind of management and orchestration capabilities, multi-cloud computing infrastructure. We combine all resources and computing node into one multi-cloud infra concept and provide some management capabilities so that users can deploy multi-cloud application or global application, whatever they want, in multi-cloud aspect. So we basically we provide to user, we provide some recommendation features, so users can get best cloud, optimal cloud resources based on their requirement. And then using this unified API from all CSPs, we can create, provision all the resources required to consist this multi-cloud infra. And actually we put all required resources into one logical concept, MC infra, in short, MCI here. And then we provide infra orchestration feature. We can provide some management in parallel and some automation. So in Cloud-Barista, there are core two sub-project, subsystem. First one is CB Spider, and second one is CB Tumblr. CB Spider usually cares of standardized this unified API, cloud API, and actually adding cloud drivers for each cloud service provider. You can think it is kind of adapter. And we are keep doing this, and top of that, CB Tumblr work as finding optimal cloud and consisting multi-cloud infra and orchestration feature. So for that we harvest all the important information or metadata from cloud service providers. As you can see, for virtual machine and managed Kubernetes node spec, we gather this kind of specifications from Alibaba, AWS, Azure, GCP, and so on, NAVER Cloud, Tencent Cloud. And there is also price per cost, price per hour, cost per hour. And we can provide more than 100,000 specification, and we analyzed, we standardized some way to specification for node. So among these 100,000 specs, there's 7,000 GPU included spec as well. So without Cloud-Barista, you may have to know this kind of information. And also you need image to deploy virtual machine and Kubernetes node. You need base OS image and some images with some applications. And we also harvested 400,000 images and identifies those types of those images. That image is in Ubuntu 24 or Windows, and the image support GPU or not. The image is for Kubernetes, managed Kubernetes or not, and yeah, we need now architecture Azure, right? Most of cloud service provider provide x86 64, but these days some cloud service providers provide virtual machine or bare metal machine, and you need this image if you want to use. So we are keep extending our supported cloud service providers and resource types. You see, it is the live docs. Whenever we cover new cloud service provider and the resource type that we provide, we mark, and the picture has been finished, we mark it as yes, blue color, and there's some issues or there's no supported APIs, then we mark in different color, and we try to cover, we try to fill this table with all blue color first, and then we try to add more cloud service provider and cloud resource types. Currently, we support virtual machine, CPU type, and GPU type, virtual network, VPC, subnet, security group, SSH key, volume, network load balancer, and managed Kubernetes, and site-to-site virtual private network, VPN. And we are currently adding some S3-like object storage feature as well. So we are keep doing this job. It's two lots of job actually. And I mentioned before we can create this kind of multi-cloud infrastructure from to generate multi-cloud infrastructure. We gather all the resources from cloud service providers, and we provide in network layer, we provide supernetting and some scale-out features, data disk and security group, and like that we provision this kind of multi-cloud infra in easy way. So how can you use this Cloud-Barista? So maybe you can use this Cloud-Barista to deploy multi-cloud on-demand AI service. Yeah, there's a Cloud-Barista mark, and if you your users, if they are here, then with Cloud-Barista you can easily deploy virtual machine server with GPU based on your requirement. And then this Cloud-Barista provides some remote command capability like Ansible, so we can easily deploy AI services consist of several open source projects. So if our users here, then we can put here whenever we need. So based on the Cloud-Barista, we can deliver high quality AI service on demand anywhere in the world, regardless of cloud service provider. So I'm going to show how it actually works. So this is a demo to utilizing Cloud-Barista, and all the basic setting can be done by two commands. Docker compose up and initialize, and you can access to this kind of GPU, and as you can see, all cloud service providers already has been registered and ready for use. So with some requirement with GPU, so to deploy some kind of LLM model, we need more than 24 gigabyte memory for GPU. So we can describe it and find the specification and image that fit your requirement, GPU requirement. So I'm going to select and configure 8 virtual machines that has GPU capability. So by just simply clicking, you can create 8 MCI consists of 8 GPUs, and we have some post-configuration capabilities. So we made the GPU driver, CUDA driver, automatically set up when it initialized. So yeah, you can click, and then you see there's a multi-cloud LLM base over there. And then I make some kind, I'm going to add virtual machine for web UI it is user interface, open source user interface for Ollama. So here I'm deploying Ollama LLM servers for each 8 VMs MC LLM with one click. Then all VMs will have Ollama service. Yeah, Ollama service is active and with the NVIDIA driver. And I'm going to download different LLM models, DeepSeek and GPT, and those models to distribute those different LLM foundation models to Ollama, 8 Ollamas. It is also just one click. So once it has been finished, those one will have Ollama with the each LLM models. And currently this one try to install Open WebUI for Ollama to see how actually the LLM models has been deployed to this MC LLM. So once WebUI has been deployed here, we can access to the WebUI. So it is not part of Cloud-Barista. We are just using this WebUI and Ollama. We provide just the infrastructure. So yeah, I didn't make any other configuration for Ollama. I did it through Cloud-Barista and select those deployed 8 models here, and then we can check those models are actually works. Maybe you can compare. If you are a researcher for LLM, different LLM models, then with the Cloud-Barista, you can quickly do your base setup for your experiment. So next use case is kind of game service, distributing large global service. So if your users are spread over the world, we need not just one service, but multiple services. So with the Cloud-Barista, we can deploy all the servers that covers worldwide. And I'm going to deploy 3D FPS game server called Jonotic. It is also open source. So I'm going to show this on Azure. Yeah, we can just configure the MCI with maybe 8 VMs, and then you can just request, and it generates the infrastructure, and we can quickly deploy the Jonotic game server Azure. Yeah, same procedure, like that. You can click. Yeah, once it has been deployed, then you can access to Jonotic game client and see our live servers are actually deployed. Yeah, if you search by Cloud-Barista term, then yeah, there are 8 cloud Jonotic game servers. So I'm maybe close to Korea, so I can select the server that provide a fast response time. So it is one tip for developers, and since I'm using this Jonotic game for demonstration and testing purpose, so I'm very free to do game in my office. Nobody don't touch, even though I'm doing game. So yeah, it is kind of a tip, and Jonotic open source is also very nice for your demonstration as well. Yeah, I actually have been explored AI services so far in perspective of multi-cloud and Cloud-Barista. So I actually interested in those technologies. So I have been covered Ollama and Llama, RAG, RAG, NHN, Workflow, and those things, and also Ray distributed machine learning platforms. And I think it is now time for MCP. So I think everyone knows what is MCP, Model Context Protocol. And people usually say it is kind of USB-C, but I'm not sure. So I hope to compare what is different aspect of MCP. This figure shows general service and API servers, SQL servers. And using this service, this application side, client side, need to develop API client and SQL client. So even before MCP, LLM and LLM agent could use this service. But in order to use, we needed outside knowledge for this service. For instance, we need to put all the API descriptions in here. So we need development. So if we generate another agent, we need additional one. But in case of with MCP, we put knowledge here and develop here this server. Then if we have just this server, those new AI agents do not need additional development. So that's the reason why people saying MCP protocol is kind of USB-C. Yeah, and we created the MCP server for Cloud-Barista. So running out of time, so I'm quickly through some slide. And once you deploy Cloud-Barista setting, as I mentioned before, that consists of we can provide all the Cloud-Barista cores and MCP server and some protocol proxy into one Docker Compose setting. So once you deploy the Docker Compose, you will have this capability. And we have some details, but I'm not going to cover. And if you are interested, you can check this reference. And this is a short demo, but time is already over, so let me quickly move the slide. And I just asked to MCP LLM that connected to Cloud-Barista MCP create 15 virtual machines regardless of cloud service providers. So actually they are the LLM agent are doing. Actually it is VS Code Copilot. Yeah, they create this kind of large infrastructure, and I just click this configuration is right and do it. And I'm going to deploy the web server to this deployed multi-cloud infrastructure, and I just ask. Then the MCP server deploy Nginx and AI-generated website for Cloud-Barista easily. So we can have these 14 web servers with the Cloud-Barista. And maybe it should be localized for each regions. So I asked the localization for the website, and so according to the location of the server, it provides localized website. So you can just use Cloud-Barista to set up this kind of demonstration. And another demonstration is to make a roulette game for Cloud-Barista for this session. And I asked to this LLM agent that just provide this one. Provide a roulette game, deploy a roulette game for this session. I just ask, I just vibe, then agent and Cloud-Barista do the rest. Even though there's failure, it retries. Keep retries and reach to the success, and then deploy it, and I can just access. Yeah, as I mentioned before, it generated roulette game, and it generated the computing resource Azure by using Cloud-Barista. So with some vibe, you can get this kind of game, and congratulations, you got echo back. So in this remark, I mentioned I introduced the Cloud-Barista, multi-cloud, and MCP integration. I guess it is kind of foundation and POC of vibe. So are you confident, or you got lots of questions? But don't worry, it is just started. So we are looking for collaborations and contributions. And if you wanna test and contribute, you can just access to this repository that I'm maintaining. Also, we have planned to collaborate with the cloud native community. So plan to submit donation for this project to ShaneShape Sandbox project. So thank you. Thank you for listening.